so a root with an even index. Sounds weird. This is probably a mix of terms that would be not my favorite. You could take out root and maybe throw in the word radical. I am referring to like roots, like square roots and cube roots. So if you want to throw the word radical in here, that's what I mean by root in that case. Not like where it crosses the x-axis. That's a different kind of root. So I'm sorry if that's, you can cross that out and put radical in there for all that matters. So if I say it's an even root, I'm going to say it's, let's do the square root. And one thing that we don't write, which is part of, remember, the square, is there would be a little 2 there, an unwritten 2. And that's important to note because later on when I say cube root or fifth root, you can do roots of any amount that you want. It's just that we write that in there if it's anything but 2. And so when it's 2, we leave it off because we use it so much. Go back to my pink. Let's do this one. Let's do x plus 1 again because it's, let's do x plus 2 for variety's sake. Ooh, those clash. Ooh. Okay. And values that don't work. What do you know about, what's the radical deal? What can't you do in radicals again? Square root of a negative. So that's a different limitation. Square rooting negatives, not so good. But I can set up, in this case, I can say it's all reals. You're certainly welcome to say so. Except one of the things we can't put in there is we have to find out what values don't work. Now you say negative 2 doesn't work. That works. That gives you 0. It's less than. Cool. And so you're saying less than negative 2. Exactly. You can eyeball it, figure it out. If you don't want to do that, which sometimes I'm just not willing to take that on, all we're looking for is to find when this would be less than 0. The stuff under the root, stuff under there has to be greater than or equal to 0. So what I'm going to do is look for where it violates that rule and use that as my exception. So x plus 2 less than 0, that'd be the violation I'm looking for. Solve for that and you get what you're talking about, negative 2, anything less than negative 2. If I subtract 2 from both sides, you get x less than negative 2. Remember, solving inequalities, subtraction and addition don't change the inequality. Except, now I can write this in here, x less than negative 2. So the domain is all reals except for x's that are less than negative 2. And we get it from setting that thing, the internal piece, what's under the even index, to be less than 0. Okay, again, another even index just for kicks. 2 would work to the 4th power. So by even, I mean this number here, the root that we're taking, has to be even. It has to be a 4 or a 6 or an 8 for this rule to take place. If it's odd, you can have negatives. So you don't have to have a limitation. It's actually any number you want. So if I took the cube root of some function, it's all real numbers. There's no restrictions. You can have negatives under a cube root. It's okay. If your function is a realistic model, it's number 3, then it may lead to have only positive values for a domain. So realistic means like in the context of it. So I'm going to just give you some ideas. If you're talking about area, realistic as in context is real. So you have to look at it. If I say, for instance, this would be a good area would be a good example. So we're saying we don't have negative areas. Unless you're talking like some super cool physics like, what is it, gray matter and some of that negative particles. There's some stuff out there that's theoretical physics that might talk about negative area and have some meaning. We're not going to go there because I'm not smart enough. Maybe you guys could talk about it. But how about, oh, I don't know, what else do I have for an example? Or some stuff, weight. So if we're going to do pounds. Those kinds of things. Things that are normally positive. Etc., etc., etc. If the functions contains any of 1 through 3 above, you will need to consider all cases. So, and that just means you guys have, we just clued you in on if you're dealing with denominators, you set them equal to 0, find out where the restrictions are. If you're doing with even radicals, you set that thing to be less than 0 and find out what the restrictions are. Anything else, this is, you should fall nicely into place, so I'm going to leave it at that. I think this kind of over-explains it in number 4, so I'm going to drop that off right now. But the notation you got to know, you have to know different ways of writing it. So x greater than 5, these are all other ways to write intervals. So you could write your domains like this. You could write this. There's one missing I'm going to put in here. Let me make one up. On far right here, I'm going to put in -2 less than x less than 5. Okay, that's my made up one. We'll get to that one last. But in the meantime, x greater than 5, things you could write in there are, I could put 5 to infinity. That'd be a good way to do it. It's not inclusive. Notice a parenthesis because there's no equal sign in the inequality. On a number line, you can actually do it that way as well. You can actually say, circle 5 on a number line and do the open circle business and then arrow to the right. That works well. You can also do, instead of an open circle, you can do the parenthesis in the number line. So here's one more. Maybe I'll do blue just for fun. Deep, deep blue. And do an arrow that way. You can use the parenthesis or an open circle. Both are fine. Okay, all kinds of good stuff. Buenos dias. Oh, good. I get to fix attendance. Gracias. Isn't this nice? He's walking in, he's like, I missed the notes. Oh, no, you did. You just go onto Google+, you go to my YouTube channel, and you will find the notes hidden in there. I'm actually getting a reasonable turnout. People are showing up. -infinity to 0. Bam! That's a good one for less than 0. But if you don't have time to watch YouTube videos of mathematics, which is silly, why wouldn't you have time for that? 0, everybody has time for that. It's fun. You can do the open circle, you can do the parenthesis, you name it. I'm not going to draw every one every time. I might just kind of waffle back and forth. Or, of course, means both. If you're going to do it, though, with interval notation, I think I'm going to maybe quit on the number line business, just kind of roll with the rest. But I will show you interval notation for this third one down here. Or maybe let's just do A, B, C. Call that C. We'll call this D, E, F, and my new one, G. Got it. But C, -x less than 3. So you're doing -infinity. I'm going to go big, big, big. -infinity up to 3. Stop. Don't include it because it doesn't have an equal sign. Union, we're going to unite this with our x greater than 10, which is start at 10, go to infinity, don't include 10. So that's the interval notation. That's really what we're all about. Interval notation, you can do it on a number line, but we'll mostly do it this way. I'm going to pause. Preguntas. Any of this got you? So far, so good? Okay. We did a little of this last week, but we're just refining. Greater than or equal to 5. We'll just put that. I goofed up even from the start. Greater than or equal to 5 on D. You start at 5, you include it. It goes to infinity. It's awesome. If I were to do the number line, which I probably ought to do just at least once for that one, you have a number line going on. Let's throw some red in there so you can define it a little bit. It would be a bracket at 5 or a closed dot at 5. So that's one option. Or you can put the bracket in there. Like I was saying. Should I erase? I haven't erased much. Ooh. Let's do that. Bracket. You can do it that way too. Both are fine. Circle, bracket, closed circle, or a bracket. Número dos. Let's go back to blue. 2 less than x less than 10. I guess there is a between one. Darn it. I thought it was left off. So G is going to be a defunct problem here in a minute. But 2 less than x, this means between. I'm going to put underneath there. If you have a smaller number on the left and you have a bigger number on the right and x is in the middle, what we're actually saying is that x is somewhere between 2 and 10. That is the notation for between. And it includes 10, but it does not include 2, carefully noting that there's an equal sign by the 10. Notation intervally, is that, can you say that? We're going to say it. Bracket on the 10, just a parenthesis on the 2. Not equal to 7. This is the fun one, so that let's get E there. If I say x not equal to 7, so let's say in f, I solve this problem 1 over x minus 7, and I'm saying, what's the domain of this function? You say it's everything but x equals 7. That means, that's what I'm implying here, by the way. You would write interval notation negative infinity to 7, can't be 7, so we'll put a parenthesis there. Anything up to 7, but not actually touching it, united with, in union with, 7 to infinity. This actually is a means of excluding 7. It may not look like it, but by putting the parenthesis on both ends of the 7 there, it's not including 7. It's not included. It's not happening. Yeah. We're going to knock out some of these. Timer. Tell me what we got. It is 10:23. We go till 48, and I want to give you time to play a little bit, so I don't want to talk all the time. We get to finish this tomorrow. Okay, up. We're going to turn the page. Come on, double finger. I got to give you these equations. They're little empty boxes. It's so funny. All right, the first one at the top. That is supposed to read f of x equals radical x plus 3. Oh, yeah. Okay, so just to go back to some of the rules, if you've got a radical, you take the internal contents and say, hey, it's got to be bigger than 0. Okay, so it's got to be bigger than, right? Can it be 0, though? 0 is good, so I'm okay. So bigger than or equal to 0. That works. This is one way to do it. Or you can do the limiting factor. You can say, all right, so I'm going to put in, this is one round. This is not something I showed you before, but we can show, let me finish this out real fast. Solve this. Solve it, get -3, right? Hey, this is kind of a positive way to look at it. I'm saying it must be, x plus 3 must be greater than or equal to 0. X is greater than or equal to -3. It's kind of a positive perspective. It's just saying, hey, just as long as you make that thing greater than or equal to 0, that's great. And this ends up being our domain. You can write it intervally as 0. What did I say that? -3, right? -3 to infinity. As opposed to, you can also say x plus 3. But I'm going to highlight this. I'm going to say this is kind of my favorite. I like this positive outlook on it. Just saying, hey, x plus 3 has to be bigger than or equal to 0. It's very positive, right? Or you could do the negative. Negative's what in red, usually. Or, and it's not a bad negative. It's just like, you could say that x plus 3, set it to be less than 0, and get x less than -3. I think that's attendance set that I hit. I'll get it, I promise. Hi, Ellen. Yeah, did you, okay, we have an update. Everybody's here, and I believe you sent me with one excused tardy. So David came up. Okay. Yep, that makes everybody here. You bet. Bye-bye. So I didn't hit Andre. Okay, x plus 3 less than 0. Everything but x less than -3. The only reason I put this in here is there's a great time. Sometimes it's nice to just say it's anything but that. But do you see the difference between the two? Does anybody enjoy the positive light on this? Like saying, just say what it's supposed to be. It has to be 0 or bigger. Okay. Should we do another one? Real quick, right next to it? You like that one? We'll do one more radical in a second here because they're all like that. We'll do a double.